S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Wave nature of particles. So in which how the matter waves are associated with the particles only. So their mathematical expression, that things are also calculated. So I am Narendra Kaur. So now I will explain how the mathematical expression if the waves are associated with a particle and what is the name of that waves, that I will explain you. This topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. So now let us begin the topic. So that is the wave nature of particle. So that is explained by firstly considering the de Broglie hypothesis. According to de Broglie hypothesis, the waves which are associated with particles are called matter waves. So these are called the matter waves and they are different from electromagnetic waves. So what are the matter waves? These are the waves which are associated with moving particles. These waves are associated with moving particles. And according to this hypothesis, when the particles are in the moving condition, when the particles are moving, means their velocity is non-zero, waves are associated with these particles. Waves are associated with these particles. Waves are associated with the particles and that waves are known as matter waves. And if the lambda is the wavelength of the waves, then that can be considered as lambda. Now we will derive the expression for the lambda and that is given as h by m into v. So this is the wavelength of the matter waves. Now this can be calculated like this. So firstly, we want to see what is the physical significance of this meaning, this hypothesis. What is the physical significance behind this? Physical significance means in day-to-day life, like if we are also the particles, we are made up by the atoms or the particles. So whether the waves are associated with us or not, so that can be calculated like this. Now lambda, that is equals to h by m into v. What is m here? That is the mass of the particles. What is v? That is the velocity of the particles. That means lambda, that is the wavelength. It depends on here the lambda, it depends upon mass as well as velocity both. Now in our cases, you can say that for the human bodies or for the heavy bodies, this m mass, that is very large. Mass, that is very large. So automatically if m is very large, so then lambda, that will be very small. But it is not zero over here. That means if m, because in our human bodies or the heavy bodies, now this lambda, that can be zero when this mass is infinity. Because we know that the reciprocal of infinity or 1 by infinity, that will gives us 0. But here mass or velocity, they have some value. They are non-zero over here. They have some value. So that means if they are very large, then lambda that will be very small over here. That means the lambda is small. Now if the lambda is small, so automatically this is non-zero. That means wavelength is associated with us also. That means the wavelength is associated, but it is negligibly small. Here the wavelength is associated, but this is associated with us, but it is very small over here. So that means here the lambda that is equals to h by mv, that is non-zero. So it means in daily to day life with the human bodies or with the heavy bodies, wavelength is associated, but we cannot see it with the naked eye. So that cannot be seen. This is just like that of the rotation of the earth around the sun. We know that the earth continuously rotating around the sun, but we are not feeling its rotation because its mass is very large. So that is similar over here, according to which, so this is similar over here. So lambda that is associated with each and every body or each and every with the material body, but it is very small. It is very small and it is non-zero. Now we know that here E that can be taken as mc square. So this is the Einstein expression, according to which the energy and mass, they are interconvertible to each other. So E equals to mc square. Now we know that here the momentum that can be also taken as lambda upon, that is the mass into velocity also, m into c square. So E that can be written as, so put its value, that will be equals to P into C. So energy that can be written as P into C. Now we will get over here the lambda that will be equals to H by P, that is equals to H by M into C. So this is a lambda here, wavelength over here. That means in case of light or the electromagnetic waves, in case of light, we will get here lambda equals to H by M into C. That is in case of light, because we know that the light waves, they are moving with velocity of light, that is equals to C, which is 3 into 10 raised to the power 8 meters per second. So lambda that is equals to H by P over here. Now for the material bodies, P that can be written as momentum, that is a product of mass into velocity. Mass into velocity, that will be V. So lambda that can be written as H upon M into V. Now another expression for the lambda, that will be equals to H by under root of 2m into E. So that can be written as, means for the moving particle, if E its energy, that is equals to half m into V square. Now we can calculate our value over here. So 2E into m, that can be written as m square into V square, which is equals to P square over here. So that means P square, so this implies P square that is equals to 2m into E. So P that can be written as under root of 2m into E. So that why, so we can write as lambda equals to H upon P. So that is equals to H upon under root of 2m into E. What is E here? That is the energy of the particle, or you can say that now the particle is moving here. So its energy that is equals to kinetic energy. So this is a kinetic energy of the particle, which is equals to half m V square. So that means the lambda that will be equals to H upon pi under root 2m into E. What is m here? That is the mass of the particle. So this is the another expression for the wavelength. Now second, when there is a charged body. So we are firstly here deriving the different expressions for the lambda. Now when there is a charged body, or you can say that the charged particle or the charged body having the charge Q, and it is moving in the potential V. Here V, that is a potential which is applied to the particle, because we know that in order to move the charged particle, some of the potential that must be applied. Now if this is a positive, then if the potential is applied like this, positive and negative. Now here is a positive charged particle, now it will repel this, and it will attract this. Then it will start moving. That means the charged particle will start moving when we are applying some potential over it. Now when the potential is applied to the charged particle, the energy of this particle that can be stored in the form of electric field or in the form of energy E. So now that means on the moving charged particle, its energy is stored in the form of E, which is given by Q into V. So this is the energy which is stored in the charged particle, energy of the charged particle which is stored in the particle due to applied potential. Due to applied potential. So the wavelength expression, here the lambda is equals to h by under root of 2m into E, which is written as h by under root of 2mq into V. So this is another expression for the wavelength. Now the different expressions for the wavelength are, first expression is lambda equals to h by p. Next is the lambda equals to h by m into V. Then lambda is equals to h by under root 2m into E. Then next lambda is equals to h by under root of 2mq into V. So these are the four different expressions for the lambda. What is lambda here? That is a wavelength of the matter waves. So lambda is a wavelength of matter waves. Lambda is a wavelength of matter waves, the waves which are associated with the moving particle. Now special case, here there comes in special case, the third expression, in which when we are taking a charged particle equals to electron, when the charged particle is equals to electron. Now in case of an electron, we know that its charge, that is 1.6 into 10 raised power minus 19 coulomb. Its mass, that is 9.1 into 10 raised power minus 31 kg. Now H, that is a Planck's constant, that is 6.6 into 10 raised power minus 34 joule per second. So filling all this value in this expression, here lambda is equals to h by 2me into V. Now substituting all these values, we will get lambda equals to 12.29 divided by voltage angstrom. So this is a value of wavelength which is associated with the electrons. So this is a wavelength of the electrons. Wavelength of electron moving with, or you can say that moving under the potential V, moving under the potential V. Now we will stop for the short break over here. So till now, okay, we have studied the different expressions for the lambda, that means different expressions for the lambda, that is a wavelength which is associated with the matter waves. Now next we will study the difference between the matter waves and the electromagnetic waves and do some of the numerical problems related to this.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Now before going to the break, I explained you the different wavelength expressions for the matter waves and also explained you the de Broglie hypothesis. Now I will explain you the different how the lambda is associated with the matter waves, how it is calculated, and the distinguish between matter waves and the electromagnetic waves. Now we know that the different expression for the lambda is derived. So lambda is equals to h by m into v. How this can be varied? Now the lambda is directly proportional to Planck's constant, that is a constant over here. M is a mass and v is a velocity. Now how it is varied over here? That means when the mass is very large, lambda that will be very small, or you can say that it is a negligibly small. Second is a v, that is a velocity of particle. Now when the particle is stationary, stationary means v is 0, then lambda that will be infinity. That means it is undetermined. Here infinity means that is undetermined over here. We are not able to determine the lambda. That means with the stationary particle or with the stationary bodies, lambda wavelength is not associated. Not associated over here. That means the matter waves are associated with the moving particles only. So when the v is 0, lambda is infinity. Next, when v is infinity, then the lambda will be 0. That means when we are not able to define the velocity, it is very large. Infinity means we are not able to define, here we are not able to define velocity. So that is a undefined. It is undefined over here. Then lambda that will be 0. That means no matter waves are associated with the particle. So this implies in order to calculate or in order to understand the matter waves, so in order to understand the matter waves or the waves which are associated with the moving particles, so here lambda that is equals to h by m into v, this v must be definite. That means if that is measurable, so that we can, if we can measure the velocity, then their lambda that can be measurable. So their lambda that can be calculated or measurable. So that can be calculated. So this is an important part over here. Next is a next expression, the lambda is equals to h by under root of 2m into E. What is E over here? Here E, that is a kinetic energy of the particle. That means lambda is here inversely proportional to under root of E. So when we are plotting the graph between, if this is the E energy of the particle and if the lambda, that means it is decreasing here with e raised to power 1 by 2. So wavelength is decreasing as soon as the energy goes on increasing. But E here can never be 0 and the lambda can never be infinity. So that means with the moving or associated particle, kinetic energy is associated with them. Automatically you can say that wavelength is associated with them. So that is varying here with the parabolic, or you can say that with the inverse parabolic condition is over here. Also the lambda that is equals to h by under root of 2m q into v. Now what is q? That is a non-zero here. That is a charge on the charge particle that can never be 0. That means depending upon the value of q, the lambda associated with a moving charge particle that can be calculated. And when we are taking for the electron its expression is 2.29, here that is in angstrom divided by under root v. Again what is v here? That is a potential over here. So that means a wavelength that is inversely proportional to v, or you can say that v raised to power 1 by 2. Again, as soon as a potential applied to the particle that is goes on increasing, potential to the charge particle goes on increasing, its velocity goes on increasing, automatically the lambda that will be goes on decreasing. So again there is a variation of potential and lambda, again like parabolic variation is there. As soon as the V goes on increasing, with the parabolic the lambda goes on decreasing, because we know that when the potential is goes on increasing on the charged particle, its velocity is goes on increasing. So automatically its wavelength that will be decreasing over here. So this is the physical significance of wavelength over here. Now second is the how the matter waves are associated with electrons. Can we see this? This is a very important question over here. So how the matter waves are associated with the electrons, and why we are not able to see this, or can we see this? Yes, as the electrons are particle. Electrons are particle over here, and matter waves are associated with them with very large value here, because their mass m that is very small, that is a 10 raised to minus 31 kg. So mass of the electron that is very small. So as their mass is very small, automatically we know that their lambda is very large. But wavelength associated with them that cannot be seen with the naked eye. So that is equals to h upon mv, or you can say that that is a 12.29 upon under root v, that is angstrom. Here angstrom means it is 10 raised to minus 10 meter. So this is a wavelength which is associated with the electrons. Now next is a difference between matter waves and electromagnetic waves. This is a very important. Now if this is the matter waves, and then is the electromagnetic waves. So first important difference is that the matter waves are associated with charge moving bodies, the matter waves are associated with moving bodies or moving particles. They can be charged or not charged. So it's not dependent if they are charged or not charged. So matter waves, are main important point is that matter waves are associated with moving bodies or moving particles. Now what are the electromagnetic waves? Electromagnetic waves are associated with charged bodies only, or you can say that charged particle or charged bodies. Here their motion of the charged particle, or they are moving or not, so that is not required over here. Or you can say that these are associated with the accelerated charged particle. Accelerated waves or charged particle. Now next is what is the velocity of matter waves? Their velocity of matter waves is given by m into v. Here v is a velocity of matter waves, so that can be greater than c. What is c here? C is the speed of light, or you can say that speed of electromagnetic wave. But here the velocity of it can be varied over here. It can be greater than equals to c, greater than c, or it can be less than c. So that means v is variable over here. V can be equals to C, it can be less than C, or it can be greater than C. So that is varied over here. But in case of electromagnetic wave, their velocity is fixed. Because the electromagnetic waves are the light waves, and we know that the speed of light, that is fixed, and which is equals to 3 into 10 raised to the power 8 meter per second. Now next is the third point. So matter waves are, for their propagation, no medium is required. There is no medium. No medium is required. That means they can travel in the vacuum also. So there is no medium. When the particle is moving, whether the particle is moving in the medium or particle is moving in the vacuum, the matter waves are associated with it. But for the electromagnetic waves, the medium is must. So this is the important part over here. Next is the fourth one. Matter waves are not seen for heavy bodies. Means they are mass dependent. They are mass dependent. Here matter waves are not seen for the heavy bodies, but associated with the heavy bodies. They cannot be measured. But in case of electromagnetic waves, they are independent of the mass. They doesn't depend upon the mass of the bodies, or you can say that mass of the charged bodies, they are fixed always. So matter waves are always associated with the EMF waves are always associated with the accelerated charged particles. They do not require a medium for their propagation. So this is the all about the magnetic matter waves and the electromagnetic waves. Now in order to calculate lambda, that is for the matter waves, lambda h is given by m into v. Now here the lambda is given by, so in this case lambda is given by, that is equals to, we know that here E equals to m into h into nu, or nu equals to c by lambda. You can see that here nu equals to c by lambda. So lambda equals to here c by nu. What is nu here? That is the frequency of the light waves. So in case of matter waves, lambda equals to h by m into v. So it depends upon the mass and velocity of the moving particle. Now here the lambda equals to c upon f, or you can say that c upon nu. So that is the frequency of light waves. So for the electromagnetic waves, they are depending only on the frequency. Their wavelength depends on the frequency only, while for the matter waves it depends upon the mass also. So this is all about the concept of the de Broglie hypothesis and the difference between the electromagnetic waves and the matter waves, and how the electromagnetic waves are moving with the constant velocity, and how the matter waves are moving with the charged bodies or the not charged bodies, or you can say that only with the moving bodies. So this is all about the de Broglie concept. Thank you. If you want to study this topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. Now if you like the video, kindly like, share and subscribe this video, and also you can press the bell icon for the future notifications.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.